Hi everyone, and welcome to a short video on trying to describe the project I worked on. So you should be looking at the screen already. It's a desk lamp, an adjustable desk lamp with adjustable legs. And I'm trying to, the purpose of the video is basically to explain how I was able to come up to this. And some lessons and skills I also made or learned while making this lamp. So if you're watching and you haven't done this before, you can definitely look into trying it out. And if you're also like a pro and you have some tips for me in case of next time, I'll definitely appreciate something like that as well. Okay, so just a brief introduction on myself. I'm Kingsley, studying at a college in Newfoundland, Canada. And I recently took into learning a CAD course with Onshape. I really like the software. I think it's a really good software. I haven't been able to use the application version yet. I only use the web version, and I think I really like it as well. It's very seamless. I had literally no troubles using this. So I think there's also an app version. If you wanted to try that as well, you definitely can. I'm sure there are also some other applications. I know of AutoCAD, Autodesk, sorry, and a couple more others, Fusion, SolidWorks, if you wanted to check those out instead. But yeah, so just go right into the video on how I was able to make this. So the very first thing I did was actually to get a model of what I wanted to build. There are a couple of ideas that were in my mind, but I just sort of building a lamp because it's something we use almost every day if you're a student, and it's just something that I felt would also be a good way to practice the skills I learned, because I could use the assembly function in Onshape to design how the lamp should move and animate. And so that was basically my thought process in picking this out. The next step really was to get a model. So I needed to know what I wanted to design, right? I actually spent a long time trying to get a 2D drawing of an adjustable lamp that fits the design or what I had in mind. It took me a long time. I really didn't find anything. I checked the manufacturer's pages. I checked some pages like IKEA, for example, to see actual dimensioning, but none of them were detailed enough for what I wanted. So I actually found out a website, GrabCAD. It's a community that basically you could see some 3D models of something similar to what you want to build. There are a lot of CAD files here. You could get the DWJ files and then import it to a system where you could measure like the parts or figure out how they move. And so that's actually what I did. I was able to get a file from GrabCAD, a swivel desk lamp, and that's how I was able to dimension and measure the lamp that I wanted to assemble or design. So that was the very first step. There are also some other similar websites to GrabCAD. I don't know of those other ones off the top of my head, but I know I saw like one or two more others. So you can also use those ones as well. Or if you have like a 2D drawing, then definitely you can just get right onto it. So that was the first step, getting an actual basis for the design. The second step and the second thing I did was to import that design into a CAD system that could allow me view it and also dimension it. So what I used was Autodesk Viewer that helped me to look at the parts that were made for the assembly. I had to import this into the DWG file into Autodesk Viewer, and you could see from the model browser the parts that make this up. It shows here. Yep, it shows a couple of parts that make this up. There are a lot here, and they're close to 20, if not more. The good thing is some of them are duplicated, like the screws, the connectors, the legs, for instance, some of the springs. So the duplicated files means, or the duplicated part means you only need to build them once. So that was basically this step. I spent like the majority of the time, I would say, in actually dimensioning it, because I wasn't able to dimension it automatically, really. So I really had to manually measure each part, each face, each surface, each height, each depth. I had to measure every single thing. So it was one of the, it wasn't hard, it was just long, because I had to be very detailed about each of those parts. And just to give a brief explanation on what I mean by having to dimension it and measure each part. So basically, you see the number of parts that are made up in this lamp, starting from the base plates, the connectors, the legs, the spring body, the axle, up to the middle connector. And so starting from one of them, if I wanted to measure the base plate again, I really just had to hide everything else and then just show what I wanted to measure. And then there's a measure tool in Autodesk, and then you just really just start measuring. Measure the diameter. Of course, for a circular plate, you want to know what the diameter is. So it says 210 here, and what I did to be why it was longer and more precise, I would say, was because I had to do it more than once. And the reason for that is you don't want to do it just once, in case, because it's not like it's not going to be very accurate. So just measuring it from two different sides just makes me feel more confident about the measurement that I was able to get. And I also had to do some estimations. I wouldn't say it's 100% accurate, just some reasonable estimations based on what I was seeing. So the diameter of this is given as 210 approximately. I had to measure the height, for instance, how tall it was. And you'd see in a minute why measuring more than once was really good. So yeah, so you see, like, I have 3 different values, but then after one I have one close to 10, but then after measuring it a couple more times, I was able to get something more close to the answer. And the reason for that is the cursor like latches on, it might latch on to the actual face of the top instead of the side, then you would not be getting the correct height. So I just had to do that a couple more times to figure out exactly what the dimension of each one was. And I did that for the base plate. I did that for all other parts that were in this model, and little by little I was able to dimension my drawings to look very similar to this. And just to show you what I mean, I can start from the base plate here. Yes, so this was basically the base plate, what you just saw there. It definitely looks very similar. I was also able to model the stands that were at the bottom, the extra supports for the base plates. I was able to get this well correctly, the width, just to show you what I mean. I can just open the top view. Yes, so the diameter was 210. There was an inner diameter that the ridges that were under the base plate on the supports, I had to do those as well. So yeah, I definitely learned a lot of features in drawings with Onshape with this project. I was able to learn the linear and circular patterns. I think those are like my really favorite patterns or features in Onshape drawing and sketching, because it really allows you to like duplicate a drawing or a feature or a pattern into, if you wanted it to be linear, if you wanted that across a piece, you could do that. If you wanted it circular, you could also do that as well. I had a lot of instances where I was able to use that. I also like the constraints features in Onshape. I like where it is, because I used AutoCAD for a while, Autodesk for a while. I didn't really enjoy how difficult it was to constrain a particular feature, but I definitely like how you're able to do that in Onshape, and then as you progress, it shows you with the different colors to let you know if your drawing is fully a dimension and the constraints are properly applied. So that was definitely something I enjoyed with Onshape. There are also some things I had to learn along the way, like the trim. I used the fillet a couple of times. I used the mirror. I also love that feature as well. So yeah, I basically had to do that for all the parts that were in this model. The ones that basically gave me a much more harder time were the connectors. I wanted to be really detailed about the connectors, and I could just show you the first one. That's this one here. Just trying to figure out what the name is. Yeah, so this one was the first one, and it was really I really had to be detailed about this one, the connectors here, because yeah, like if you could see that they are both the same really. So it's basically the same thing, and then there is a piece at the bottom here, as well as this is where what connects it to the base connector, to the lamp base. So I really just had to be very detailed on how I was able to assemble this and build this part, just because I knew that almost all the items, like almost all the other parts, were built from this, like the legs for example go through the holes, the springs as well. So it just had to be and the knob, I just had to make it as detailed as I could make it. And I can show you an example of that, the base connector. Yes, so definitely it's almost it's a close similar. So this is where the legs go through, this is where the springs also go through. All the connectors were really not so easy to work with, so I think all of them gave me a tough time. The middle connector would be somewhere here. The middle connector is up here. Okay, and the problem I had with this was the fact that it wasn't a horizontal, like, or a vertical piece. I had to specify a lot of angles in this. It was also really confusing because you wouldn't know what would be your base x-axis or your base y-axis to be able to dimension this properly. So that definitely gave me a tough time, but eventually I was able to get something very similar, a close, basically the exact same thing. And I think that's also why I like the symmetric feature for the extrude in Onshape. It basically just allows you to focus on one side and then build something on the other side. Like, it shows you don't have to extrude for both of them. It just does that for you automatically. And yeah, you see how heavily this was dimensioned. There were a lot of things that had to be done for this. This had to be fillet. The inner lines as well had to be fillet. There are a lot of arcs here, circles. It was just a lot to build this. I think this was the longest out of all the parts. But eventually I was able to build it. It just took me a bit more time. And I was also able to get the angle. You can also see that there are some angles I had to use here, 105, 126. Luckily, Autodesk also had that feature for me to measure angles, so I was able to do that there. And so I basically just use this to build each part little by little, piece by piece. This is the top connector as well, and that's the piece right here. Top connector, yes, that's the piece here. So it really just took me some time to build each of them, but I was able to do that. I think the hardest one that I still didn't get as accurately as I would have wanted would be the lamp connector. There were a lot of shapes here. I just didn't know how to do it. I had no idea. I think I can agree to be defeated on this. I was able to build something very similar, but even I know it wasn't as good as it is. This shows the two parts together because I just wanted them built together, but I'll show you in the main assembly how they were able to come together. Well, I just tried to do something very similar at least, and yeah, I was able to get that. And so after doing that, the next thing to do was the assembly. So all the parts have been built individually, and the next thing to do was to build the assembly and figure out how each part would animate together or move together. And I think what helped me for this was actually watching some videos to understand how I want it to move, right? So I was able to check online. I checked YouTube. I mentioned earlier that IKEA has something similar to this. I also checked their page. I checked for a video to show how it should move, and just to show you in the drawing before going ahead to show you in the main assembly. So how it should move is this leg should be able to tilt forward and backward, and then this middle parts of the lamp should be able to tilt upward and downward. So it basically allows you a lot of rotation of the lamp. So it's highly flexible, it's very adjustable to the perfect position you want it to be. Also, the lamp connector, the lamp head should also be able to move up and down for you to tilt the lamp upwards and downwards. So that's what I got by watching the videos. And so the very next thing to do would be to actually start building and assembling this piece together. And to do that, I actually like the sub-assembly functions that Onshape have, where you could build an assembly and then import that assembly into a different assembly. So I was able to use that a lot here. The first thing I had to assemble was the spring, because the springs are the ones that basically allow the lamp to rotate with the degrees of rotation I mentioned, or the degrees of movement I mentioned initially. So the springs has the spring body as well as the spring axle. And then if you could visualize it, if this is moving this way and this is moving that way, it means that you want this to be able to extend when it's being pulled. When it's being pulled this way, it should be able to extend out of the body, and when it's being pulled backward, it should be able to contract or go inside the spring body. So pretty quickly I was able to realize that that was a slider mate that I wanted, because the slider mate allows you translational freedom around between the two items or the two parts. So that was what I was able to get with this. And I was also able to use the offsets, the limit function, to figure out exactly where I want it to stop and how far it should be able to slide to. Of course, it wouldn't be shouldn't slide to the very end, such that the knot would disconnect from the spring, because if this goes fully in, it wouldn't be held anymore here, so that wouldn't make sense. And also, it wasn't meant to come out fully out, so I really just had to use some limits to control how much it moved, and that's what you see here. And then to animate and show how it works, this should show how it works. So yeah, it goes all the way down, but then after getting to the limit, it goes back up, because there's a limit, like I said, to how much it could actually travel to, and then there's a limit to how much from here it could go. So a slider mate helped me to achieve that. I just wanted it simply translational in one axis, back and forth. And that's what the spring assembly was. I used this 4 times, so it made more sense to make it a sub-assembly and then build it in a bigger assembly. And the next thing I wanted to do was the base. So the base is basically the base of the lamp here, this piece. And for this base as well, I wanted this spring connected to the leg is basically what drives the whole rotation of the base. This leg also does, but if you see here, the leg is connected to this middle connector, and they are both connected. So just rotating this or just moving this would be able to move this one as well, and in turn this. So I didn't need to fix this to any rotation point. I just knew that they would move together. And so the next thing I did was, for the base, I had to define how they moved. So the legs, they moved, the legs had to rotate. The legs had to rotate about this base connector, because you wanted it to move this way and to move that way. So that's a rotation, or a revolute mate in Onshape. The other thing was The spring on the base connector also had to rotate because the spring would have to move this way and also that way, also a revolute mate. Now, what I needed to actually figure out, this took me a while to figure out, but the mates that I needed for the spring on the leg. So remember, I wanted this to be able to rotate this way and that way, but it's actually connected to the spring. So moving this moves the spring as well. But if the spring is connected to this and the leg is connected to the base connector as well, it wouldn't work. So what I was able to figure out was a cylindrical mate, um, where you could allow the cylindrical mate on the leg allowed this to rotate. It allowed the spring to rotate about this axis, but it also allowed a translational movement as well. That way, when you rotated it this way and you moved it left and right, then the spring axle would be able to come out of the spring body and allow it to move that way. That's similar to a piston. So that's what I was able to do. It took me a while to figure that out actually, but yeah, I was able to do that, the cylindrical mates, and then to just show you how it works. That's an example of how it works. So I also had to fix some limits on this to fix how it was able to move, because I didn't want it moving all the way down here. So I just had to fix some angles, limits in how the the brake leg, that's the leg connected to the springs, moved. I had to have that fixed. After that, I did the middle connection. The middle connection was pretty much similar to what we just did here. This is a cylindrical mate. It had to rotate around this leg, but it also had to be able to translate, so it could come out and then go in. And just to show you how that worked, it comes out here and it goes in and all the way down there. So I also had to make some limits as well to how this worked as well. And finally, I was able to actually import all the sub-assemblies I just built into the main assembly file, and I was able to build it fully. So this is the angular limit I talked about. I wanted it to rotate just between 0 degrees to 75 degrees. So when you see it rotates this way, after a while it stops due to the limit. I didn't want it to go all the way down because of course that also wouldn't make any sense, and it would cause too much strain on the base, on the middle connector as well. Yep, that's basically what I was able to do. You see just a full animation of how it works. It's able to rotate this way, left and right, there, and it's also able to rotate up and down, and the lamp itself is able to rotate up and down as well. Yes, just for very high flexibility of this lamp. Something I was not able to achieve with Onshape was having a knob. For instance, if you had a lamp and you had like it was very flexible and you wanted to only adjust it left and right, you don't want it to also be adjusting this way. Like you want to be able to fix one rotation while you rotate something else. So a knob would have helped me to do it in real life, because I just needed this this to go in as a knob and then just hold it in place so that you could release the knob if you wanted to rotate the upper part, and then you can tighten the knob if you just wanted to rotate the legs. Onshape couldn't do that, so even if there's like a fasten mate here, it doesn't actually restrict the movement. But either way, I think it all came out well. I was able to have it assembled as similar as this. It's pretty much very similar to this, and yeah, I was able to achieve that. It took me a while to actually complete. I would say like 2 to 3 weeks to complete. Just the fact that I had to manually measure each of these pieces again and again and again, because like any wrong measurement would give me issues in the future. Because just for instance, the base connector had to be connected to the legs. The radius of the holes of the legs has to be similar to the holes of the base connector. If not, it's going to throw up an error when you're trying to revolute it here. So I had to have that taken care of, and eventually I think I'm really pleased with how the design turned out. Definitely lots of things to learn, maybe in being faster next time, but like I said, I'm always welcome to tips. So if you have any helpful tips for me in case of next time, just let me know. I would be glad to take them in. This was the connector that I talked about. It's not very similar to what is the actual piece, but I think I'm pretty close. And I had the help of a friend in designing this. So if you're here, allow me. Thank you so much for helping me designing this. I think the colors really look good as well. But apart from that, that's pretty much it. Like I said, any tips are definitely welcome. Thank you so much for watching this video, and if you are someone that would want to do something like this in the future and you have any questions for me, I'm definitely welcome to answer any things like that. Thank you and bye.